I'm going to talk about, at least talk about the shallow lakes and the deep changes, or we could call this presentation When the Shallow Lakes Will Disappear, because eventually it seems like also the shallow lakes in Europe are not endangered ecosystems right now. I do believe that in a couple of decades, it could happen that they're not only going to be endangered, but they probably will disappear. So this is my logical slide why they have to disappear. Somewhere around in the 60s, the ecologists came up with the theory of alternative states. It took 30 years for a limnologist to understand it, and eventually they implemented it for lakes. So the idea of the alternative stable states in shallow lakes is that there is an intermediate state that to any perturbance will shift into two different stages. One is the macrophyte stage, which means that eventually the ecosystem will go from a lake to a grassland and hopefully to a forest. So eventually it will disappear. Or the other alternative state is the algal state of the lake, when the lake will be dominated by one or two species, and the biodiversity of the lake will completely diminish. So from natural perspective, the lake as it is won't be usable in any way. So this is the two alternative states, and this is the first reference to when it was first mentioned in papers. Since then, here, it was written in 1994 1993. As far as I remember, since then, lots of supported this idea. And the idea of it is that the intermittent situation, that is, everybody likes most of all, because there is a clean water, there are macrophytes, there are high biodiversity. With any smallest degree of intervention, will go either to one of the two possible states. So the intermittent state is not stable. These both are more or less stable. So we're gonna, who's rooting for the team B or the team C? We're just gonna count on which one gonna win. So, I just gathered, for the sake of showing your presentation and my data, all the major factors that I think that are influencing the shallow lakes right now, mostly in Hungary. Why it is an interesting and important question for Hungary or for Pannonian georegion? Well, it is important because we have 4 big lakes and all of them are shallow. By shallow, I mean that the definition in limnology of the shallow lakes is that a lake that is by average wind blows is the whole water body will be perturbated. So the Lake Balaton is on average 3.7 meters deep, but is considered shallow because the average lake winds around the lake will disturb the whole water body. So I know it's not unfair to start with the eutrophication, but then again, since Lake Balaton had a great history of coming through eutrophication and oligotrophication since the last 50 years, it is useful to start with it. So we already knew that what could happen if excessive amount of nutrients will appear in the shallow lakes. It will eventually, within a couple of decades, will become eutrophic. The process of eutrophication is sometimes considered as something artificial. No, it is sometimes naturally occurs, but it takes hundreds, sometimes thousands of years for the eutrophication to take its effect, while the human effect is just completely visible. So within a decade, Lake Balaton became eutrophic. Unfortunately enough, there was a consensus between the government, the scientists, and the water authorities what we have to do. And this solution were implemented in the end of the 70s and beginning of the 80s. This should be taken as an example. It's probably one in the world example when the governmental support of the scientific approach resulted in a positive results. It brought positive results. So we thought the problems are solved. But somehow the nature said for us, oh, sorry, it is not very visible, but since 2019, we not only take a look at the scale of the eutrophication. So the smallest, the 50 microgram per liter, is already eutrophic. So whenever you see a color in these maps, it's already eutrophic. So you see, since 2019, we constantly have problems with Lake Balaton. They are sometimes local, sometimes maybe concentrating on one basin, but look at this year. This year, nobody mentioned in the newspapers, nobody talked about it. Oh, sorry. Nobody talked about that seemingly all the Lake Balaton is eutrophic was this year. And this is only one example. We have 4 lakes, and all 4 lakes were eutrophic this year in Hungary, in total. So this is one of the examples that leads from towards the algal state, dominance of the algal state in a shallow lake. What about the hydrological regulations? We know that the majority of the Hungarian lakes are recreational on purpose. In a law, they are written down. This is a recreational lake. Don't bother with the nature, don't bother with approaching some green ideas. These are recreational ideas. And these images are showing it perfectly, how concentrated the water regulations of the lake, for example, Lake Balaton, towards the recreational purpose. Well, I was a bit, you can notice the tendencies, the green that are showing the highest annual fluctuation of water on the top. It is because they are the most natural annual water fluctuations. And you see the red one shows the average of the water fluctuations, and you see some of them, and these are the really dry years that happened in the beginning of 2000 and the beginning of 2010s. So these are accidental, these are natural processes, and this is what the water authorities unfortunately still trying to maintain for recreational purpose. Again, these artificially overstabilized waters are not natural. So eventually they will lead to the algal state. I'm not going into the scientific side of it, but it seems like since 2019, this new eutrophication processes is not influenced by nutrient inflow into the Lake Balaton, but it's coming from inside of the whole body of the water, for example, in case of Lake Balaton. So again, I think that this tendency of overstabilizing the water level in Lake Balaton and in all lakes of Hungary will eventually lead towards the algal state, preferential algal state of the lakes. Then again, I combined, for the sake of shortening my presentation, in the pollution, the shoreline reconstruction, and the tourism into one group because they are somehow inter-affected. For example, in Lake Balaton, it is especially important, but it is also, you can observe it for the other shallow lakes of Hungary, that the urban part of the lake is dominant. 2/3 is urban, and 1/3 of the lake is, well, let's call it natural. But this natural occurrence is not, so here is the building, and next to it is the green, very diverse area. And this is the best implementation to show how the urban effect goes beyond the borders of the cities. This is a light pollution image from 2 August of 7. This is the satellite image that I was using it, and I colorized it for you, and it shows that it goes beyond, the light pollution goes beyond the cities. It means that we can use, for example, light pollution to show how the human affect their surroundings. Why it is important? Because humans not only intervene where the urban areas are. For example, here is the walkways. I just used the satellite image and just line up all the walkways within Lake Balaton. And you see, the funny part is that we have around 1,700 walkways, and we have 240 kilometers of the perimeters of the lake, but only 80 kilometers, which is green, reed stands. So if we divided 1,700 by 80 kilometers, we find out that we have every 60 meters a walkway in a reed stand that results in this sort of images. Absurd, I can understand. But what is more important, if we go back, that 400 of them are official. The majority of them are, the quarter of them are official. The rest of them are unofficial. So this is official, this is not, this is not, this is not, this is official, etc., etc., etc. Water authorities are trying to maintain the lawful situation around Lake Hungary, and not Lake Hungary, Lake Balaton, but it is beyond their capabilities right now. And the last one, that is probably something of, we do not know what's going to happen, so we just trying to made up some ideas what's going to happen in the next couple of years, but thankfully to the Water Authority datasets, we were able to look back for the last 150 years and check how the water temperatures, this is the water temperatures, the number of heat waves, lengths of the heat waves, and the heat wave intensities changed in Hungary. This is sort of an average, let's call it an average. I won't go into the details how we come up with this data, but it includes all the major lakes of Hungary, so Lake Balaton, Lake Velencei, Lake Fertő, Lake Tisza, all the major rivers, and some of the smaller rivers. And this is what we are facing right now. We do not, it's not a prediction data set. It's the data set that already happened. So we have 0.7 degrees on average increase per decade in Hungary, all the water bodies. Okay, there are differences. The lotic systems, so the rivers, are warming up slowlier, while the lakes are warming up a bit quicker. The larger lakes warming even more, so Lake Balatoni is warming the most, while the smaller lakes will definitely. But this is what we are facing right now. We do not know what's going to happen next year, because this is not climate models. This existing data. And you see, it's not linear. The problem is that sometimes I was able to fit logistic equations to this data. But if the changes are persistent for the next 2 years, there will be no possibility to fit logistic. That stabilized, I don't know, somewhere. All the possibilities, next possibilities, will be exponential for the future. So these are the changes that could affect, and the climate change obviously will affect the amount of water in Lake Balaton. So what we are facing right now, if the climate change will take effect and evaporation will decrease the water amount in the lakes, the amount of macrophytes will increase in it. So yay, Team Macrophytes is getting 1 point this time. If the evaporation is happening the way that we are predicting. So in this case, it's mostly the climate change probably will mostly result in the disappearance of shallow lakes by increased growth of macrophytes.
Dr. Tóth, you have 5 minutes left.
Yeah. So alternative stable states, and this is the result. One for the group B, where the macrophytes are winning, and 4 for the algal state increase. So eventually, as I said, the shallow lakes, as we know right now, will disappear because there is no possibilities to maintain their situation. But the most intriguing part is that when I show you these graphs, there is no natural factors. All the factors that you see here are human. So if we stop interfering with lakes, probably the problem won't go away, but it won't be so dramatic as I hopefully described for you. Couple of conclusions, and I leave you here with thank you very much for your attention.